All right. Hello, everyone. Good afternoon. It's always nice to see some familiar faces in the audience. Thank you all for taking the time. In our session, we'll talk briefly about the pros and cons of retrofitting an existing building versus building out a greenfield facility. So a little bit about myself. My name is Saif Sabti. I work for SSI SCHAEFER. I head the business development and the strategy function. Been in the industry since 2005. My passion is to really use technology and engineering solutions to solve problems, and I apply that to logistics solutions and fulfillment. So, before we get into the session, I'd like to use a show of hands to know how many people in the audience currently have a semi-automated or an automated facility. Okay, so maybe 10–15%. We have a short video to roll just to give everybody else a perspective of what an automated facility looks like and what would be the growth path in those facilities. I'll narrate the video as it goes. It's about 3.5 minutes long, and then we can get into the slides and the pros and the cons of retrofitting buildings. So.
SSI SCHAEFER is a trusted partner for pharmacies worldwide for automated storage, distribution fulfillment, and product validation. This 200,000 square foot distribution center located in North America provides the latest technology for accurate retail fulfillment. To ensure patient safety,
so this customer need is a retail fulfillment facility maximizing both goods to person and also robotic fulfillment.
100% of product orders. At the same time, the guarantee of accurate product fulfillment.
The size of these facilities
during their peak season
range greatly. There are very small facilities that can fulfill below 1,000 orders a day, and there are very large facilities that fulfill in the north of 100,000 orders a day.
Arrive daily from manufacturers.
Automation can apply to all types of facilities depending on ROI, and that's something we do.
Starts. For pallets containing only
this is the
SKU,
receiving process, which happens to be semi-automated with assisted robotic depalletizing. We'll talk about that in the retrofitable solution
a
option.
Unique identifier and a storage location within the SSI mini load. For pallets that arrive with multiple SKUs, the depalletizer removes the case and places it on the conveyor. Cases then go to one of 6 decanting stations where product information is scanned and recorded. There are 4 verification stations and 1 centralized teach-in station for individual units.
As this application is pharma related, there's an additional verification step. For many retail applications, this step is not there.
The information is fed to WAMAS, the warehouse management system by SSI SCHAEFER. Once decanting and product identification have taken place, the product moves automatically to its storage location.
In this application, we use a variety of ASRS solutions. There's a mini-load ASRS solution, there is a shuttle, single-level shuttle solution, or QB, and we also use a single-level shuttle solution for order fulfillment and staging.
Once an order is placed, an empty tote makes its way to the A-frame area where ultra-fast picking occurs. SSI SCHAEFER
picking in this application is done both with a goods-to-person solution and also robotically. Robotic picking is done with an A-frame solution, and there's also a robotic piece picking system as part of this system.
Orders are picked from the A-frame area first. For any items that did not match the item master file, the order is rejected and sent to a manual picking station to confirm the item or items. For orders that are complete, they are sent to order verification for final validation. Otherwise, they are sent to consolidate with items that are picked via the robotic piece picking station.
These are goods-to-person workstations. They are part of a robotic, they're part of a manual picking solution fed by an ASRS system.
7 piece picking robots, which perform a
This is robotic piece picking system. It's supplied by the same ASRS, however, the picking here is done robotically.
Which limits any type of handling. Once orders are fulfilled, order totes go to shipping preparation and are then buffered in the shipping SSI QB. From there, they are released in sequence to the palletizing robot once all totes of an order are in the shipping SSI QB storage area.
This is order
Once bins are
palletizing.
ready
In
for
many
shipping,
facilities,
an
this is
SSI
done
SCHAEFER
manually.
palletizer
In this
powered by
facility,
Wama
this is
software
robotic
arranges the bins
palletizing.
on a
It
pallet in
considers
order of shipping
route
out for easy
priorities
delivery.
and it builds
SSI
sequence
SCHAEFER
or
provided a
reverse
holistic
sequence
solution
pallets
products
for
that mandate
order
100%
fulfillment.
accuracy. The entire process is managed by WAMAS, the WMS solution by SSI SCHAEFER. Order verification is important in any industry, but it's mandatory when it comes to healthcare.
We can go back to the slides. So this is an overview of what I would say largely automated facility maximizing the scope of automation. What we will discuss in our session today are really a path to upgrade the capability of an existing facility, be it semi-automated or fully automated facility. Why is this important? Why is this discussion important today? Well, there are many aspects. Let's list a few. The job market is still exceptionally strong. It's still very difficult for retailers and end user to fulfill warehouse jobs. There are significant market uncertainties, and there's also the labor market and the money market is in a lot of flex. The balance between interest rates and inflation hasn't been reached, so that contributes to the uncertainty in decision making. Also, parts shortages in delivering technology and other solutions still exist today. It's gotten better, but even in our own projects, we still experience shortages related to material shortages. So, what does that all mean? It means that investment decisions are clouded by all of these various aspects, and end users are often faced with the decision of, do I grow my existing facility or do I build out a greenfield facility? So the way the presentation is structured is this. We'll look at these four possible options. These are the four possible decisions, and then we'll provide avenues by which you can gauge these decisions by. The first one is the pause and wait, the retrofit, the expansion, and the greenfield facility option. So, pause and wait. What does this mean? This is essentially leveraging the existing system and using this phase as a data gathering phase. What are some of the improvements that could be achieved as part of this phase? Well, one, you could implement process improvements such as lean processes or Six Sigma to get more out of your system. Sharing best practices among sites. Certain sites are historically performing better than others, so trying to figure out how do these sites do it? Can those lessons be moved over to other sites within the network? A data-driven approach, root cause analysis for any operational related problems is always a good way to get more out of an existing system. Also, developing better operational visibility. So many WMS solutions have the data within their data warehouse. It's exposing this data out and allowing the operational staff to make decisions out of the available data. And then we look at the maintenance aspect of it, looking at the preventative maintenance schedule, trying to optimize that, and also exploring some employee retention program as an option as well. So what are the benefits of this kind of solution? Well, it's minimal capital investment relative to the other solutions. It's limited operational investment. Yes, there is cost associated with training and retaining staff, but it's relatively small compared to other solutions. And there's also no disruption to existing operations. The drawbacks far outweigh the benefits, of course, in this case. There is limited to no improvement over the operational operation. What does that mean? It means that this year's peak will most likely be as hard or maybe more challenging than last year's peak. There are also possible loss of market share for a retailer or an end user. There's also a possible decrease in customer perception as a result of it, and also waiting to implement this change will increase the gap between the need and the future state, which will make that implementation even harder in the future. So let's now look at a retrofit. And the way that it's structured is as we move along these slides, the complexity of the solution increases. So a retrofit is retrofitting an existing system, staying within the footprint of the building. So how can operational improvements be achieved in this kind of solution? Ability to accommodate additional SKUs by adding ASRS. You could minimize the impact of downtime by adding redundancy. An example of this, if there's a labeler line or if there's a pallet stretch wrapper line that is constantly causing issues, redundancy could be added by adding an additional redundant line. That would increase the availability of the equipment and allows you to get more out of your equipment. Incremental throughput through additional workstations. We saw in the video various goods-to-person workstations, and we also saw additional robotic workstation. And a retrofit could be to add additional workstations or to add additional robotic piece picking cells. Implementing a SCADA software within the facility. A SCADA software allows maintenance staff to get better visibility and hence faster response time to any system downtime. And also implementing a CMMS, which is a maintenance management system that allows you to manage the maintenance staff much better or in a more efficient way. One of the benefits, well, relatively speaking, this is low CapEx investment and also shortest ROI. It's also the fastest path to operational improvements, and it leverages your existing trained workforce. So less disruptions to operations. Now, the drawbacks are there are disruptions to operations. I mean, you think about it, you are building out an expansion to a system within the same footprint. So there's construction, there's installation ongoing while operations are trying to fulfill orders. So there are disruptions. There's possible increase of project cost. Some of these installations, commissioning and testing would have to happen off hours or over weekends, or sometimes multiple attempts can be made to connect the systems together, which add inefficiencies to the installation. Also, there's a possible reduction of capacity as the project is being implemented. So let's look at an expansion. And an expansion is really a broader version of a retrofit. It's building a bolt-on solution onto the existing property of a building. So what are some of the operational improvements that could be brought out of this solution? One, you could expand the scope of mechanization. For example, in the video, we saw robotic palletizing. That could be incorporated as part of an expansion solution. You could take a manual solution and automate it with this additional footprint. You could also automate the lower end of your ABC curve, bringing more SKUs into automation, hence increasing the amount of orders that are fulfilled by automation. Adding additional throughput, this is a common one with a retrofit solution. It could be by adding workstations or robotic picking solutions, and also reducing replenishment frequency. With a larger ASRS system, you could hold more inventory, you're able to replenish less, and with that, there's less reliance on labor to replenish the system. And also minimizing downtime by adding redundancy in the system. This is another common one that is shared with a retrofittable solution. So what are some of the benefits is you leverage your existing property, the existing land. There are minimal operational disruptions. This is a separate building per se. It's a bolt-on solution. The systems would have to be connected towards the end, but as the project is being built out, this is done in a separate footprint for the building. There's minimum impact on throughput. For most operations can continue to operate independently as the project is being implemented, and there's lower overall project costs relative to a greenfield, and you can also leverage the existing workforce. Of course, you would have to scale it up to be able to support the larger system, but you could leverage the existing workforce. What are some of the drawbacks? It's increased costs as a result of doing this phased approach, and occasionally this could also mean a longer project lead time. Testing, for example, would have to happen off hours, and the off hours testing would result in overall larger or longer lead time relative to a greenfield facility. So We looked at the no decision option, we looked at the option of a retrofit, and we looked at the option of an expansion. And the next one on the list is really the greenfield implementation. This is a new purpose-built facility based on the current and future data. What are some of the benefits? All the previous benefits in a retrofit and expansion apply, in addition to some of these. One, it's a purpose-built fulfillment facility. So all the learning from previous facilities can be applied in improving the process flow of this facility. It is designed for the current data and also projected data. So you could look at your existing customer base, your existing data, and grow that for the future. Reduce equipment maintenance. This is newer equipment, so significantly less maintenance, of course, and also lower operational costs as a result. And the benefit of the solution is it allows for piloting new technologies that could then be deployed at scale at the same facility or future facility. Typically in a retrofit or an expanded solution, oftentimes you're deploying more of the same technologies as opposed to having this fresh idea approach of trying out or approaching new technologies. Benefits, it's opportunity to optimize flows within the network, so you could essentially redraw the entire flow of the site. Access to a new labor pool, this may be a benefit, and also the ability to optimize the overall fulfillment network. So many of the greenfield facilities that we work on is a customer or an end user or a 3PL is looking to optimize their network by possibly consolidating 2 or more fulfillment facilities. So you're taking two sites within your network, or maybe 3 sites within your network, you're consolidating into one and then deciding for the best location for that network. And also, this consolidation could have an overall cost reduction for the fulfillment network. What are some of the drawbacks? Well, it's overall higher CapEx in investment, possibly longer ROI, but I would also argue that in the case of consolidating multiple facilities, ROI for these kind of facilities is still extremely attractive. Land availability and also choosing the proper site is also a constraint, but it's a solvable constraint. So we've defined really 4 options and defined some of the pros and the cons of existing within the existing building. This is retrofit, expanding, or building out a greenfield facility. And the next set of slides is taking 10 decision drivers. Of course, this is not a comprehensive list. I'm sure end users and operators have additional items that they could add to this, but it's a concept that we're essentially presenting to sort of say, these are some decision drivers that would need to be considered. And at the end of the deck, we take the decision drivers and the possible decisions and combine it together in a decision matrix. So existing space, that's one of the most common ones. It's the first one that end users or operations look at. Is there existing space within the building? And also, what is the building condition? This ties into ceiling height, it ties into slab requirements. Is the building upgradable? The next one is land availability, and I would say this is the obvious one for an expansion and also a greenfield. For an expansion, is there available land to expand? Is it in the right location relative to the rest of the network? If a customer was to locate a new site, where would it be located relative to the network? So these are some of the decisions. Other drivers that go into this decision include seismic requirements, labor pool availability, zoning laws, etc., and also the proximity of the site to logistic amenities, whether it's ports, whether it's interstates, etc. Location, and location ties into customer data, and this is where I would say for these kind of studies, we always recommend a data analysis of current order profiles to leverage this data in making the decision. And the location looks at the customer location, it also looks at the number of orders, and looks at orders density to figure out where is the ideal location for a future site. If it's the current location, this argument would support an expansion or a retrofit. Or if the current location is not ideal for various reasons, then this will vet itself or lend itself more to a greenfield facility. Labor market, I would say that's an obvious one. If the current site is in a good labor market, there's access to labor, relatively speaking, also trained staff within the facility, then that would support the decision of staying within the existing building. If there are many constraints and there are issues in acquiring trained, qualified labor, then that would lend itself to more of a greenfield facility. Operational impact, and this is really talks about operational impact tolerance. Is operations able to endure or tolerate some changes? If operations are already operating at a red zone, they've gone through a very difficult peak and difficult times are continuing, this may not be the best time to implement a retrofit solution, and that would lend itself more to an expansion or maybe even a greenfield facility. So some of the things to consider as safety training, of course, operational change management to make sure that operations is aware of this change and implement any training and procedures in place before the change is implemented. Building code and infrastructure, that's an important one, is checking the specs of the building. Is the slab requirements able to receive an ASRS solution? That is an important consideration for ASRS solutions. What about power requirements? What about IT infrastructure? Would upgrading a portion of the building result in the rest of the building having to be upgraded because of code compliance? All of these items need to be considered, and we would recommend that they're considered and be factored in the overall cost of making this operational improvement. IT infrastructure, this is talking about a WMS or an ERP. Is the existing WMS system a legacy system that is difficult to upgrade? And then moving to a greenfield facility, implementing a new WMS solution may be an option. So these are some of the considerations that have to be made in the IT infrastructure. This is on the software side. On the hardware side is, what are server room considerations, what are IT infrastructure considerations that have to be made in order to add this new ASRS system. Order and customer data, I covered this briefly, and this is really the order data analysis to leverage customer order, whether it's quantities, whether it's the split between B2B and B2C to support this decision, delivery locations, and also the split between pieces, cases, and pallets in terms of order profiles. Timeline, what is the desired timeline within the organization to see a change? And typically, I would say this is one of the biggest drivers. Sometimes there is room to grow and implement in greenfield, but occasionally the situation needs to be improved quite quickly, which would lend itself to a more of a retrofit or an expansion solution. Product considerations, again, this ties back to the data analysis. We always recommend a slotting analysis of the existing building to look at the velocity of items, what items are in existing automation, what products are currently in a static rack, for example. Are there some improvements that could be done in preparation for implementing this new ASRS solution? And product considerations, are there high-value items? Are there freezer-rated items? Are there multiple temperature zones? All of these considerations have to be put in place. Typically, an ambient solution is easier to implement than, for example, a freezer or a multi-zone or a multi-temperature zone type facility. Investment ROI, and I'll close with this, this is the most critical factor, and in many cases is the deciding factor. It's not really the CapEx, it's the overall ROI. And all these other factors feed into the ROI decision. So, presented 10 decision drivers. I wouldn't say we captured every decision driver. I'm sure there are other decision drivers that operators and end users would have. But in many cases, these are, let's say, the given ones that would have to be considered. You have various options. There are the decision drivers, and in the next couple of slides, we essentially try to put it together to present a decision tree or a decision matrix. So if we look at the impact and urgency as two decision drivers at a high level, this is a 2D matrix, and they say that within impact and urgency, there are sub-drivers. So within impact, you have the business need, the strategic fit, and also the ROI. Under urgency, you have the organizational readiness, and this also ties back to the operational readiness of that site, the customer demand, and also the competitiveness position. So the two balance each other and all lead to making that decision when the decision is weighted at the end. Now let's look at impact, for example. Some of these items are not weighted equally, and this is what we always recommend, is to apply some sort of a weighting to this decision tree. For example, for some organization, ROI is the most important decision driver under impact. So in this case, ROI has a higher rating than the others. We assign it 40% as an example. It could be higher. The same methodology would be applied to urgency to try to say what weight is each decision driver applied to. And then you take this matrix and assign some sort of a ranking system. We'd say start with 1 to 5, 1 being low, 5 being high, and high is high impact relative to the decision. And then if you find that 1 to 5 is too granular and you're having a tough time deciding between is it a 3, is it a 4, then scale that back to 1 to 3, low, mid, high. And a lot of times this is sufficient. Take that matrix and then you would expand it to essentially look to be something like this. And we'll have this available on our website to download as a best practice guide, so feel free to visit our website after the show to take a look. On the rows of this decision matrix, there'll be the deciding criteria that we've presented. And you would essentially assign a raw score in isolation of everything else, assign a raw score to the various decision drivers, and then at a following step, you would apply the weighted score, and then take the weighted score, add it up, and you'll have a total sum for both impact and urgency. Taking the impact and urgency scores and then visualizing it on this chart gives you a visual representation of a decision. The way you would read this is the top header are the possible decisions that could be made. Reading from the bottom to the top are the decision drivers ranked by their impact to the decision. We use a color code as an example, so the more impactful this item is, the closer it is to the top, and it's the redder the item is. And also the scope of impact. For example, we look at land availability. Land availability applies to expansion in greenfield, so you see the scope of land availability is really limited to these two. This is a model to visualize this impact and socialize it within the organization. This is now going to provide the answer. The previous matrix will, let's say, bring you closer to an answer, but it's a way to visually see how certain decisions impact the overall operational improvements that are required. So, in summary, various options. There are really many decision drivers listed in the presentations, the top 10 decision drivers. The takeaway from this session is define what those decision drivers are, apply some sort of weighting. You could use the matrix we presented. There are auto models out there as well, but apply a weighting factor to the various decision drivers. Make sure that you apply both an urgency and an impact, combining both based on the weight to arrive to a solution that could be visualized in a matrix to present within the organization to get to a decision. We'll be available for the rest of the show at our booth. Please feel free to stop by. We can answer more questions, but I said we'll have this content shortly also available for download. Thank you all for your attending. Thank you all for being here, and I hope that you found this beneficial. Thank you.
Does anybody have any questions? Anyone have any questions? Okay.
Go ahead.
As the provider on behalf of the customer, do you ever influence the ratings to help manage the green to red ratio?
So I didn't hear the full question.
Do you ever influence the rating that the customer may
Yeah,
provide
absolutely.
in order to help?
Yeah.
Okay.
Spot on, absolutely. So for example, let's take a look at ROI, for example. The solution that is provided heavily impacts the ROI. You know, a highly automated system could have faster ROI if it's, let's say, solving a lot of labor issues. Capital investment, that is something the solution provider has a lot of control over. Project timeline, a project provider has a lot of control over. Some of the other things, for example, land availability, a solution provider doesn't really have much influence over, but we could influence the density of the solution, so we could provide a highly dense solution to fit within the existing footprint of a building, for example. So yes, for many of them. Good question.
Any other questions?
Any other questions?
All right, well, let's give a round of applause for
Thank you
Saif
all.
Sabti, Vice President of Business Development, Strategic SSI SCHAEFER, and they're located in the South Hall, 1931 and 2331. Thanks, you guys, for coming. Have a great day.